So this is SD6103, the data system technology review homework. I choose the Milvus database. But before we start, I need to give an introduce of the different versions of Milvus and the reason why I choose Milvus Lite. You can see that there are around 6 different versions for the Milvus. It has a cluster, the standalone, and the GPU, and offline, and the Milvus Lite. The reason I choose the Milvus Lite is that the other versions just standard for the Linux. So when I use the Windows or the Mac, I need to use the Docker or the K8s. It's quite inconvenient, so I choose the Milvus Lite. This one is support for the Python's SDK, so it is very convenient for our presentation. So the first step is install the Milvus and the related package, and then this step is a test to connect the Milvus. You can see that the host IP is the localhost and the port is the default. Because the next step, we need to create the Hello Milvus collection. So for this one, we need to confirm the database don't have the Hello Milvus collection first. So you can see the result is false. And then we need to give an introduce of the collection. You can see that the collections has 3 different keys. The first one is PK. It's just like the primary keys in the my circle. And the second one is random, and the third one is embedding. The embedding has 8 dimension vectors. So you can see we created this, and then the third step is we need to insert the data. We are going to insert 3,000 data to the Hello Milvus. Data to be inserted must be organized in this field. You can see the PK value, the random value, and the embedding vectors. So just like this. And I use the pandas data frame to show the first 4 row of insert data. The first line, the second line, and so on. And calls, we use a vector database. The vector database is famous for the RAG function. So this step, we will test it. So for the first, we need to create the index using the flat. And you can see the parameters, the index we use flat, and the distance we use the L2, and this is the parameters. So after we created the index, we need to test the different search. For the first one, we search based on the vector similarities, and the second one, we based on the scalar filter, and then we test the hybrid one. Use the vector similarity and the scalar filtering. So we skip the code and continue with the result. You can see that the vector we used for searching is the last 2 vectors in the Hello Milvus. So let's continue with this result. And the first return is the ID is 2998. We totally has 3,000 data. So the most similarity one is itself. So the distance is 0. You can see just like this. And this is the other 2 most similarity one. And this line is group 2. And for the scalar criteria, we choose the random more than 0.5. You can see that this is a random more than 0.5. We set the code return just for 1 result. And this is we show the paginations. You can limit the result just like this. We limit just return 4 result. You can see that there is a 4 result with random more than 0.5. And the offset is the other parameters. It means we skip the first one and just return the other 3. You can see this is same with this one. So the last is we have the scalar criteria and the vector similarities. You can see this is the first result, the random more than 0.5, and this is the second group. So this is the main function of the vector database. The last step is to test the delete entities by PK. So let's we start with the result. Before we delete, we query for the PK with 0 and 1. You can see there is a result. But after we delete, the result is none. And after we test this, we delete the hello Milvus in the database and drop the hello Milvus. And that's all.